Hello all, welcome to ESE Electronics. This is the part 2 of a radar system video. I was receiving a lot of requests to do the part 2 video of radar systems. This is relevant if you are going for ISRO scientist or technical assistant examination or gauge examination or any exam related to electronics. Okay, so in this video we'll be seeing some more new concepts on the basis of radar systems. Okay, so let us see what is the first question. If the radar operates at a frequency of 5 GHz, then find Doppler frequency of an aircraft with speed 100 km per second. Okay, so this question is regarding the Doppler frequency. So I've seen a lot of questions in the technical assistant exam papers or question papers of this pattern, that is asking the Doppler frequency. So before answering this question, what is actually Doppler frequency or what is Doppler effect? So consider that there is a radar. I'm talking on the basis of radar. So this is a radar. Consider this as the source. Okay. Consider there is an aircraft and this is the receiver. So this source or the radar is sending some signals, right? And the frequency of this signals or this frequency will vary based on the condition whether this receiver is moving or the receiver is stationary. Consider that the receiver is moving towards or away from the source. Then the frequency will vary accordingly, and this effect is called Doppler effect. So there can be a variation in the frequency if the receiver is moving or if the source is moving or both are moving relative to each other. So the general equation for this change in frequency is given by F is equal to C plus or minus VR by C plus or minus Vs into F0, which is your original frequency. So due to the relative motion between the source and the receiver, there can be a variation in the frequency, and this is called Doppler effect. Okay, so this thing is actually happening when the trains are moving. You have seen train problems, right? Relative velocity of the train is varying. So this is actually connected to the Doppler effect, we can say. But in case of frequency, this is the general equation. So F is equal to C plus or minus VR by C plus or minus Vs into F0, which is the original frequency. VR is the speed of the receiver. Vs is the speed of the source. And C is the speed of light. Now, why this plus and minus? Because according to whether the source or the receiver is moving towards or away from the other, that is the source or receiver, that is whether this is moving towards or away, the sign will also vary. Okay, so for various conditions, that is when the source is, when the receiver is moving towards or when the receiver is moving away or when the source is moving towards or away, this equation will vary. So that is why it has been given plus or minus. But in this question, if you see, it is not given that whether the source, whether the aircraft is the receiver here. So the aircraft is moving towards or away from the radar, which is a source, right? So for that case, we can use another general equation, which is given by Fd is equal to 2 into Vr into F by C. This is the equation. 2 into Vr into F by C, where Vr is the speed of the aircraft, because here the receiver is the aircraft. F is the original frequency of operation and C is the speed of light. Okay, so in this question, all the terms are being given. You just have to know this equation and the concept. Okay, so let us substitute the equation, the values in the equation, try to find. This is a general equation. Now let us see what are the various terms here. So what is F here? F is equal to 5 gigahertz, right? So 5 into giga means 10 raised to 9 hertz. Okay, so that is F. Now what is VR? VR is the speed of the aircraft or the receiver. Here it is 100 kilometer per second. We need to convert it into meter per second. It is 100 kilometer per hour, we have to convert it into meter per second. So 100 into 10 raised to 3 by, in order to convert in 1 hour to seconds, 3600 meter per seconds. That is 100 into 10 raised to 3 by 3600 meter per seconds. Now C is 3 into 10 raised to 8 meter per second. Okay, now all the values are in standard terms. Let us substitute and find the result. 2 into 100 into 10 raised to 3 by 3600 into F is 5 into 10 raised to 9 by, that is here, 3 into 10 raised to 8. And if you solve this, you will get 926 Hertz. Okay, so the answer for your Doppler frequency FD is equal to 926 Hertz is the correct answer for this question. Anyway, let us forget about the solving part of the mathematics. You have to understand the concept of this Doppler frequency and Doppler effect, because I've seen a lot of questions with this concept, or I've seen a lot of question papers with such a type of questions. Okay, so let us see what is the next question. Calculate the duty cycle of a radar which transmits a 1.5 microsecond pulse with pulse repetition frequency PRF. It is PRF or pulse repetition frequency of 8 kilohertz. If peak power is 500 kilowatt, what is average power? What is resting time? So we need to actually find three things for this question, and we are going to study three new concepts. First one is duty cycle, then average power and resting time. So in this question, what all things are given? 1.5 microsecond pulse means it is given the pulse width. Pulse width is equal to 1.5 microseconds. Also, pulse repetition frequency is given, PRF. That is the frequency at which the pulses are being sent by the radar. It is 8 kilohertz or 8 into 10 raised to 3 hertz. Now, peak power is given. Peak power is equal to 500 kilowatt. First, we need to find the duty cycle. So, the equation to find the duty cycle is duty cycle is equal to pulse repetition frequency PRF into pulse width, or pulse 1 by pulse repetition time into pulse width. Because PRF or pulse repetition frequency is equal to 1 by pulse repetition time. We know that frequency is equal to 1 by time, right? So, similarly, pulse repetition frequency will be equal to PRF is equal to 1 by PRT. This is a relation. So, you should know all these basic concepts. So, 1 by PRT into pulse width. So, you don't need to go for the pulse repetition time because it is directly given that the pulse repetition frequency is 8 kilohertz. Into pulse width is also given. So, first we can find this duty cycle. So, if you don't know the equation to find the duty cycle, just note this down. Duty cycle is equal to pulse repetition frequency into pulse width, or 1 by pulse repetition time into pulse width. Okay, so how can we find this value? Here PRF is, what is the value of PRF? Duty cycle or DC is equal to, PRF is 8 kilohertz. So 8 into 10 raised to 3 into pulse width is 1.5 into 10 raised to minus 6, right? So if you solve it, 10 raised to 3 and 10 raised to minus 6 will be 10 raised to minus 3 here. 8 into 1.5 is, that is 8 into 15 is 120. So it is a 12. Into 10 raised to minus 3 is equal to 0.012 is the duty cycle. Okay, so this is the duty cycle. Now, we have obtained the value of duty cycle, right? Next, next question is, what is the average power? How will you find the value of average power? Again, in terms of the duty cycle, you can write duty cycle DC is equal to, we have been given the peak power. We need to find the average power, right? So, the duty cycle is average power by peak power. Okay, so we have the peak power, we have the duty cycle. So we can substitute and find the value of average power. So average power is equal to duty cycle DC into peak power. So in this equation, you know the value of DC and you know the value of peak power, right? So just substitute the value and find the result. So DC or duty cycle, DC is duty cycle, don't get confused. 0.012, right, into peak power is 500 kilowatts. So 500 into 10 raised to 3. Now, 0.012 into 10 raised to 3 will be 12. 12 into 500 will be 6,000, right? 6,000, right? So 6,000 watt, or you can write it as 6 kilowatt. So this is the what? Average power. So the equation to find the average power is duty cycle equal to average power by peak power. So average power is equal to duty cycle into peak power. Okay, so this is all about the power. Next, we need to find the value of resting time. Okay, I'm going to remove this. Let us first see what is resting time. Okay, so let us consider that this is a radar. This radar is sending pulses. Okay, so like this, the pulses are being sent. So after this duration, after little bit time, the radar is again going to send pulses. Okay, so this is the pulse width. Okay, and this is the pulse repetition time. That is, after what time the pulse is again repeated. So if you see, after sending this pulse, it is going to be idle for little amount of time, and after that only it is going to send the other pulse. This time will be very minute. Anyway, there is a little bit of time in between the sending of the two pulses, right? So this time is called the resting time of the radar. Okay, so if you see the term resting time, you should consider as this. That is the time interval between any two pulses sent by the radar is called the resting time. Now, what is the equation to find the resting time? Resting time RT is given by pulse repetition time minus pulse width. That is, after what time the pulse is being repeated minus the pulse's width is called the resting time or the gap. Okay, so here we have given the pulse repetition frequency. How will you find the pulse repetition time? 1 by 8 kilohertz means 8,000, right? 1 by 8,000 minus pulse width is 1.5 into 10 raised to minus 6. If you solve this, you will get it is 124 microseconds will be the resting time or RT. Okay. So the resting time is 124 microseconds. That is, for 124 microseconds, we can consider that the radar is idle. It is a very small time, right? So it is the time in between the successive pulses. Okay, so resting time is 124 microseconds. Actually, in this resting time, what the radar is doing, it is actually waiting for the echo. So we know that the working principle of radar is sound wave reflection. So it first sends a pulse and waits for an echo. So in this resting time, it is very relevant because it is waiting for the echo. Okay, so we have actually discussed three concepts here. First one is the duty cycle. Second one is the relation of duty cycle and the average power. Then third one we have discussed about the resting time. I hope these concepts are now clear. So let us see another question. A pulsed radar has duty cycle of 0.016. If the resting time is 380 microseconds, what is pulse width and what is PR? So this is again connected to duty cycle, pulse width and pulse repetition frequency. Okay, so what all things are given in the question? It is given that duty cycle DC is 0.016 and also resting time RT is given 380 microsecond. Now let us try to connect these terms with the other terms given, that is PW and PRF. Okay, so what is the equation to find duty cycle DC? DC is equal to pulse repetition frequency PRF into pulse width. Okay, this is one equation. Now, what is the equation to find the resting time? RT is equal to pulse repetition time minus pulse width, right? So here we have RT in terms of PRT and pulse width, that is pulse repetition time and pulse width. And also we have DC, duty cycle, equal to pulse repetition frequency into pulse width. So we can write this in terms of PRT so that we can equate. That is 1 by PRT into pulse width. Now we have the value for the duty cycle. What is duty cycle? Duty cycle is 0.016, right? Okay. Also, we have the value for resting time, which is 380 microseconds, that is into 10 raised to 6. Now, let us try to form a relation for either PW or PRT from this equation. Let this be equation number 1 and let this be equation number 2. So, how can we write pulse width from this equation? So this is 1 by, right? So 1 by PRT is equal to 1 by PRT into PW is equal to 0.016. So from this equation number 1, we can write the pulse width is equal to 0.016 PRT, right? So now we can substitute this in equation number 2. I'm going to substitute it. 0.016 PRT. Now, can't we solve this and find the value of PRT? Right. So, it is a 1 minus. So, I'm going to take a common of PRT here. PRT into 1 minus 0.016 is equal to 380 into 10 raised to, it is microseconds, sorry, 10 raised to minus 6 it is. Now, from this relation, PRT will be equal to 380 into 10 raised to minus 6 by 1 minus 0.016 is the relation, right? So, what is 1 minus 0.016? 0.000, you can write 0.016 will be, here it is a 0, 10, 9, 10, 9, 10. So 10 minus 6 is 4, 9 minus 1 is 8, 0.984. Okay, 0.984. This will be your equation for PRT, or this is a sum for PRT. Now you have to solve it and find the value. If you solve this sum, you will get the value as 386.1 microseconds will be the value of your pulse repetition time. Okay, so we have obtained the value of pulse repetition time. Now, what will be pulse repetition frequency? So, pulse repetition frequency, I'm going to remove it. Pulse repetition frequency is equal to 1 by 386.1 microseconds. So, this is your pulse repetition frequency. Now, what is, we need to find the value of pulse width also, right? What is pulse width? Pulse width or PW is equal to 0.016 into PRT, right? So what is PRT? It is 386.1 microseconds. So if you solve it, you will get is 6.18 microseconds. Okay, so this will be your pulse width. And this is your pulse repetition frequency. So you need to actually study the relations between pulse repetition frequency, pulse repetition time, resting time and duty cycle, and also pulse width. So the equations are duty cycle, I'll write it once again. Duty cycle is equal to PRF or pulse repetition frequency into pulse width, or 1 by PRT into pulse width. So this is the equation for duty cycle, and resting time RT is equal to pulse repetition time minus pulse width. So these are the two important equations you actually need to study while I was discussing this question. So these equations are important because you can see questions being asked about the duty cycle, pulse width or pulse repetition time likewise. Okay, so these are the questions which I have included in this video. I hope that this video was useful for your preparations. If yes, please do give it a thumbs up and also do share this video with all your friends. If you want more videos, please do subscribe to the channel. Thank you.